Hello and welcome back to Elementary Algebra section 10.1 on radical expressions. So this is not just square roots, right? For the family of radicals, there is also a cube root and a fourth root and so on. But those are reserved for later on in intermediate algebra. We are going to introduce just the square root today. Now, we have seen the square root in the past. We know hopefully how to compute those and where they come from, but let's have the whole notation here. So if you have, let's say, 3 times 3, that will be equal to 9. The other way to write that would be 3 squared equals to 9. And the square root is actually a backwards notation from this exponential notation. We write that the square root of 9 is equal to 3. So there is a list of these perfect square numbers that you can take the square root of, and if the number is not on the list of perfect squares, you can use calculator or approximation to come up with the answer for that square root. So square root of 121 is 11. Now you're going to say, why? Because 11 squared is 121, which is 11 times 11. And now if you don't have a calculator, you can multiply 11 times 11 on the side, right? 1 times 1 is 1, 1 times 1 is 1, and then 11 right there, and then 121, right, when you add. So you can use the method, even if you don't have the calculator, to create the list of all of these perfect squares that you can take a square root of and come up with these answers. So how much is the square root of 16?
4.
4. Perfect. Square root of 49?
7.
7. Awesome. Square root of 100?
10.
10. Square root of 196?
Ooh, you lost me.
No, it's 14. So it's 14. What I have seen on elementary algebra final, the highest is square root of 225 for 15. That's the highest I've seen. Intermediate algebra had sometimes 17, but it's not a big deal. You should know all of them up to 100, and then when you go over 100, you have 121, 144, 169, 196, and 225. So those are the numbers that are higher than 100 for square root. So 10, 11, 12, 13, 14, and 15 squared, which are the square roots, right, would give you 10, 11, 12, 13, 14, and 15. So once you know all of the square roots, there is a rule that you need to remember regarding negative signs. Now, the calculations for this rule are all in intermediate algebra, and you get a full lecture or 2 lectures maybe on what is known as complex numbers. But that is reserved for the square root of negative number. So in elementary algebra, you're supposed to write not real, and that's it, because you can't compute the square root of the negative number. Now, why is that the case? Well, if I have 4 times 4, the answer is 16, positive 16. And if I have negative 4 times negative 4, the answer is again positive 16. So in either of these cases, when I take square root of 16, I either get positive 4 or I get negative 4 when I have a positive square root. Right? I can reach both of these. But what I cannot reach is, what I cannot compute is if I have negative 16. because both of these, in order for them to be squared, have to have the same sign. And as you can see, you cannot get the negative when you multiply two same signs, because you know that positive times positive is positive and negative times negative is positive as well. You need to have one positive 4 and then one negative 4 to come up to negative 16, but then these are not the same numbers, so you can't fit the square. So either way you look at it, it's a problem, right? Now, that's solved. Obviously, in mathematics, we have a whole branch of mathematics on complex variables, complex analysis, complex this, complex that, doesn't matter. But it has that complex number I. So in intermediate algebra, you guys will have this as a 4I solution, but that's in intermediate algebra. In elementary algebra, you guys are just going to say not real. So if you have square root of negative 36, you will just say not real. Now elementary algebra will say 6I, but that's elementary algebra. This I represents a square root of negative 1, which is a problem for our mathematics because of this thing that I explained over here. So for you guys, you need to be aware that when there is a negative inside the square root, it will, if there is a negative in a square root, it will always give us the complex answer, not real, non-real answer. Now, if the negative is outside of the square root, well, we're all good, because you copy that negative and then you take the square root of 16 is 4. See, now that negative has nothing to do with the square root because it's not inside the square root. It's outside of the square root, so the negative gets copied. Negative gets copied in this case. And you cannot copy negative in this case here because it's under the square root, so the square root is applied to the what do you call it, negative number, right? Which is, now there are also graphical approaches for this and all stuff, but you will deal with that when you get there. So we actually covered most of it. Your job is to know perfect squares, right? You also have access to calculator, which you can, right, use the square root feature and just say square root of 9 is 3, right? So you have you know how to take the basic square roots, and then this game of negatives here, where if the negative is under the square root, you just write not real and you're done. And if the negative is outside of the square root, then you still get to compute the square root, right? Because square root of 16 is perfectly defined to be 4, and then there's just this negative in front that has to be dragged out. Now, the last part of this is the last part of this section is going to be dealing with square roots of fractions and decimal numbers. Now, decimal numbers can be turned into fractions, and that would make the problem easy. But we have to deal with the square root first. So how about 16 divided by 49? Now, earlier, sometime in chapter 5, we learned that a over b raised to the n is going to give us a to the n, b to the n. So each member of the fraction is going to get its own exponent. Well, later on in mathematics, you will learn that square roots actually are exponents of a half and so on. So what you do is you go and you say, all right, let's then give the square root to each one of these numbers. So you have a square root of 16 divided by square root of 49, and the answer is immediately 4 over 7, because the square root of 16 is 4 and the square root of 49 is 7. So to take a root from these fractions, you are literally dealing with the square root of the top divided by the square root of the bottom in the denominator, and then you just take the square roots independently on both of those. So let's take a look. I'm going to put maybe 2 or 3 of these. 2 fractions is enough. So 121 over 36 and maybe 196 over 49. So let's see what you guys get when you solve these.
You simplify if you can, like all the way to the lowest.
Well, if it's possible, you can, but you also have to be careful that you are supposed to take the square roots, right? So if
Okay.
you
Yeah,
if you
yeah.
sometimes you get to simplify and then run into problems.
It's the first one, 11 over 6.
11 over 6, and can we simplify that any further?
No.
Okay, so the step would be give each one its own square root and have 11 over 6, and it cannot be simplified any further, so that would be it. Cool. How about the bottom one?
Yeah, 14 over 7.
Okay, so square root of 196 divided by square root of 49 is 14 over 7, which is equal to
2 over 1 or 2.
2. Excellent. 2. Now this means that I should be able to divide 49 into 196 and get 4. So if you go to your calculator and you type 196 divided by 49, you will find that that's 4, and then the square root of 4 is 2. That will be another way to solve this problem, right? Going the other way to deal with the same thing. Okay, cool. Now the only thing that is left are the decimals, which are the best solved by, right, you guessed it, turn them into fractions and then apply these rules. Now, converting decimals into fractions, that's a pre-algebra course we teach called Basic Math, and the skill is very simple. You just count the number of decimal places, and that's how many zeros you put after 1 in the denominator. So it's a very simple procedure. I have found throughout the years that students would make a lot of silly mistakes because they want to cut corners and then obviously, right, as always in life, run into trouble. So, square root of 0.36, right? When you look at this problem, you know that the square root of 36 is 6. But you also know that the 6 is not the answer for this problem because it was a decimal, right? It was 0.36. So you can't have a 6 to be the answer for this problem. But you know that it has to do with 6 in some way. So you immediately convert this into 36 over 100. And this is what I said, right? When you have a decimal number, all you need to do is to count the number of decimal places and put that many zeros in the denominator. That's all it is. And now the entire problem is immediately simple. Square root of 36 divided by square root of 100, which is the skill we just talked about. You get 6 over 10, which is 0.6. Now I understand that you can get this obviously using a calculator. That's not an issue. But the thing is that you can also do it, right, by observing these square root rules. So our whole calculation, right, that we are working on here is always going to be the same type of calculation, right? You will convert the decimal into a fraction, and then you would go from there. Now, eventually you pick up the pattern, but when you do enough problems. So how about the 0.81? How would you solve this problem? And don't be shy.
Would it be square root of 81 over square root of 100?
I'm sorry, can you repeat that? Because it was very difficult to...
Would it be square root of 81 over square root of 100?
Excellent. So square root of 81 over 100, and you already gave me that it's a square root of 81 over square root of 100. Square root of 81 is how much?
9.
9. And the square root of 100 is 10. Good. So in technically 0.9, if you want to do that. And now you're looking at the pattern and you go, 2 decimal places to begin over here, 1 decimal place in the answer. So this square root also cuts the number of decimal places in half. Like, those are the things that when you do many problems, right, which is why we assign a lot of homework. When you do many problems, you have all of the, you are able to pick up on a pattern. Now, I'm also going to take a look at the square root of 2.25. So this one is 225 divided by 100, which is the same idea, right, what we had before. And then the top turns out to be, well, square root of 225 first, divided by square root of 100. And that's 15 over 10, which is 1.5 as the answer. You could have canceled by 5, right, and get 3 halves. That's another possible answer for this. So you can write it as a 3 halves. You can write it as 1.5. It's all good. And that's how you deal with decimals. Now, I want to, since we are done, there is literally nothing else. We are not covering expressions that actually have variables inside. You will be shoveling things like that, but if you are going to intermediate algebra, you will be upgrading this idea, putting the variables underneath and all of that kind of stuff. So that will be there. So what are we having here? Well, we have just a basic square roots, which we use all the time, right, in math courses. And the more of these special numbers, right, which we call perfect squares, the more of those you know, the better off you are. Please make sure you understand which way the negative works. So if it's under the square root, we don't have a real answer, walk away. If it's outside of the square root, you are still okay to compute. And then we have these 3 calculations here, which are the square root calculations, where each numerator and denominator get their own square root, and then you just do 2 independent problems. And the same for decimals, where we actually convert them into fractions, first using that cheap trick, and then we just go and use the square root. I mean, we use the square root the same way like we did it, like we did for fractions. And at the end, this is not in the lecture, but it's kind of cool thing. I always like this. How much is square root of 17? Right? Well, what you can say is, okay, well, the first number that is smaller than 17 is 16, and the square root of 16 is 4. And the first number bigger than 17 that it's a perfect square is 25. Square root of 25 is 5. So you can see that the square root of 17 is squeezed in between 16 and 25, which means that the answer must be squeezed in between 4 and 5. So if you look at the number line, which starts with 16 and ends with 25, we don't need all of the numbers, you see that 17 is very close to 16. So you can approximate this as, let's say, 4.1. Right? That's your approximation. So you can approximate that square root of 17 is about 4.1. Now, why 4.1? Because 16 and 17 are very close, and 70 and 25 are far away, right? They're 8 units apart. And so over here you have 8 units apart, and over here you have 1 unit apart. I could have even gone with 4.2. Maybe 4.2 would actually be a better answer. 4.2. It doesn't really matter. And then you can go in the calculator and check. So you go into square root of 17. Oops, I typed something wrong. Second. Square root of 17. Oh, my first answer was better. 4.1 was better. I shouldn't have changed it. Because calculator gives that the square root of 17 is 4.123106 and so on, going forever, right? So you see how close we are by guessing? And you can do this literally for any situation. So if you don't have the calculator with you and you are not on a perfect square, like let's say you go out with your friends, right? And the food is about to get to the table, right? Everything is perfect. And the square root of 84 comes up. Like, what do? Right? Well, you would say, I take my cell phone, but let's say battery ran out. You didn't charge it. Now, some concerning question is, why would square root of 84 come up? Well, that's, I don't have the answer to that. But you're out with your friends and square root of 84, right, came up. So what do? Well, you immediately figure out what's the first smaller number where you can take the root of, and the next larger number that you can take a root of. Oops, 10. So 84 clearly needs to be 9 point something, because it has to be between 9 and 10. And now you have the same idea as before. You start at 81, eventually you get to 84, and 100 is all the way on this side. So there are 16 units difference here, and there are 3 units difference there, right? So how about we call this 9.2 about, and see in the calculator. A 16 and a 3? Whatever. Square root of 84 is about 9.16515. So yeah, that will actually, this 5 will make 6 into a 7, and 6 would make 1 into a 2. So yeah, that's actually really good approximation. So yeah, good job, if I say so myself. I pat myself on the shoulder. So this is, again, not a part of your lesson. You're not going to see any of this stuff on homework, but just, ability to kind of guess where the answer is going to be, just by picking two numbers that you know what the answers are, and literally squeezing in between the answer. And again, you want to go closer. right? If the number is closer to the left, then those are the decimals that are closer to the left. If the number is closer on the other side, right, it will be larger decimals like 0.8, 0.7, 0.9, whatever. It depends on if I try to take a square root of, let's say, 98. Well, clearly I'm going to put that as 9.9 because square root of 98 is very close to 100. So I better approximate that with 9.9 because this is what a 10 is. At 100, you have a 10. So there's a lot of cool things that you can do like this, right, with this. But we're not going into any of the algebra or anything like that. We're only dealing with computation with numbers. And that concludes radical expressions. Any questions, concerns about radical expressions?
No?
Okay, then bye. Do the homework, right?